Hi everyone, my name is Claire O'Connell and I'm doing my PhD at Dublin City University in the School of Physics. So everyone I'm here, I'm sure, has heard about cancer, but maybe not everybody knows that it manifests in different ways. So one particular type of cancer is called metastatic cancer. And what happens is the cancer grows uncontrollably into the surrounding tissue. Now this is particularly detrimental to patients if the cancer grows into a blood vessel. That's because if the cancer can get into the blood vessels, it has access to any one of your vital organs. And obviously if the cancer spreads to these organs, it makes patient treatment much more difficult. And obviously patient outcome becomes much lower at this point. So for my research, I want to improve patient outcome. So how do I do this? I need to be able to find the cancer cells amongst your healthy blood cells. Well, the thing is, this is not so easy because there may only be about 1 to 100 of these cancer cells amongst 1 billion healthy blood cells. It's a bit like playing Where's Wally? I'm sure maybe some of you here are familiar with it, but he's the guy with the stripy hat and top and the glasses. So usually when you play him, he's kind of hard to find, but imagine doing it with about 100 times more people than normal. So we need something else to help distinguish Wally from the crowd that are all dressed so very similarly. So how about I gave him something glow in the dark, or a pair of light up glasses. That way if I turn off the lights, you'll be able to find him in a couple of seconds. This is exactly what I want to do for my research. I want to tag those hidden cancer cells with little lights. For my research, I make silica nanoparticles and I put fluorescent dye inside them. And what this dye does is it lights up when we shine a certain type of light on it. So this means now that I need to get them to stick to only the cancer cells. And we can do this because cancer cells have certain type of proteins on their surface that your normal healthy blood cells don't. And we can get these things called antibodies, which will specifically attach onto those specific proteins on your cancer cell and graft them onto my light up nanoparticle. So this means now if I get a blood sample from a patient and I put some of my nanoparticles in with them, that they should only stick to the cancer cells. And then if I shine a little bit of light on them, I say, yes, you do have cancer, or hopefully, no, you don't have cancer. But if you do, generally at this point, it'll be at an earlier stage of the cancer, so you'll be able to help the patient to have a better outcome. Also, the doctor can use this information to tailor the treatment towards that patient. So one of the interesting things about my work is that it's not just one type of cancer that this works for. It can be used in breast cancer, colorectal, lung, or prostate cancer. And these are some of the most common types of cancer that are found today. And obviously, if we can help these people improve their patient outcome and be impacting on a lot of people's lives. So fingers crossed it all works out. I've been Claire O'Connell. Thanks for listening.
Great stuff. Thank you, Claire. Do we have a question from our judges, Fergus? Judges fine?
I think it's on now. Great. So that was a great explanation, Claire. So it sounds like it's really high-tech design, I guess, on the experimental work that's ongoing there. I'm just wondering, is it, from, I guess, an end-use point of view, is it going to be high cost, or is this something that, you know, would be reasonably low cost, fast turnaround, could be used, say, in less well-off countries, say, than in the West?
Okay. So the dyes that are used inside the nanoparticles are not very expensive if you were to mass scale it. Also, the silica that is used for the nanoparticle production also is not expensive. The limiting factor is the antibodies. So they can cost a lot to produce just because in the nature of antibody production, you have to immunize animals, or depending on how you synthesize them, that can inhibit basically that's a limitation basically on how much you can sell them for. But I suppose if you mass produce it enough, you know, you might be able to get the costs down for limited resources settings.
Brilliant. Thanks a million.
Thank you, Claire.
Want to be in the audience next time? Click here for tickets to Inspirefest 2017.